So this is so here we need to understand the basics of the transport layer, right? We already know what are the main functions of the transport layer, because when we covered the layering concept at that time, layer by layer, we have gone through, right? So now we need to understand what is the main function. So you see that whenever we are talking about two hosts, host A and host B. So these two hosts somehow, either directly or indirectly, that means through intermediate nodes, these are connected. Now, how does the communication happen? So it happens via these different layers, right? We have the physical layer, we have the data link layer, we have the network layer, we have the transport layer, and depending on the model, you could have few other layers, but let us consider that it is the application layer. So if you are considering OSI, in between you have the session presentation layers also, right? But the main layer is basically application layer. Same thing over here as well. You have all these layers. So yeah, so we have the physical layer, we have the data link layer, we have the network layer, we have the transport layer, and we have the application layer. So this thing you know by now very well, that the communication happens basically layer to layer, right? So that means only the same layers, they basically, using the corresponding protocol that is applicable in that layer, they can talk to each other. However, actually, the bits are going through the physical connectivity that is there, right? Whether it is a wire or whether it is wireless. But the logically, the communication takes place between these layers. So physical with physical, data link with data link, network with network, transport with transport, and application with application. Now, till yesterday, what you have learned is how to have the packets from the sender node, that means let us say host A, reach the destination node, which is host B, right? You know that how to send the packet. Packet has been delivered, but the actual person who is supposed to get, how do you give that packet to him or her, right? So this is where basically the concept of something called end to end communication comes into picture. So this is also sometimes called process to process communication. Is this clear? So ultimately we are talking about what? We have the packet that was sent by the host. It has arrived at the host B, right? It has arrived. But what is host B? Host B is running certain applications which need that packet. So application means what? Certain processes are running. So basically it has to be fed to the corresponding process to which it belongs. Is it clear? So this is why this end to end, what are the two ends? The two processes. So end to end communication or process to process communication. Clear? So ultimately what is going to happen is this layer over here will talk to this layer logically, right? The physical communication takes place still like this, but ultimately the communication between the two layers takes place logically at the same level using the corresponding protocols. So we'll come to the corresponding protocols in the transport layer. In the network layer, you have seen that we have protocols like IP, we have protocols like TCP, RIP or OSPF, the network routing protocols that we talked about yesterday. We have those. But in the transport layer, we have few other protocols which are called TCP, UDP, using which you are doing certain assignments so far. So I'll come to the assignment part also in your lab. So this process to process communication. Now you see, when you talk about a computer, right? When you talk about a particular computer, so ultimately it has something called ports. This term also you are quite familiar by now. Ultimately, because in the socket programming that you are doing, you are using the ports concept. So this fellow also over here has certain ports. And the applications that are running on top, these applications are going to feed in the data through these ports PA, TB, PC, etc. And the same thing basically has to happen over here as well. So this is the reason you see ultimately these applications, the processes basically, they are going to get access to the data through these ports. They are going to get access to the data through ports. So that is the reason this process to process communication ultimately comes to port to port. So some people prefer to call it port to port also. Now every layer has the corresponding PDU which is logically sent, and the PDU. So for example, in the network layer, the PDU was called the packet. In the data link layer, what was the PDU called? Frames. Very good. Very good. Frames. So in the transport layer, the PDU is called segment. So very often today you will listen to me talking about segments. So segments are like the packets, but at the transport layer. So when I say like the packets in the network layer have their corresponding headers. Okay, every layer basically keeps on adding the headers. Headers are nothing but like the addresses, right? And we have looked at the different header formats, IPv4 header format we have seen. We have seen yesterday the header formats for the other protocols, RIP, OSPF, etc. Very briefly we saw, but I have shown you like there are these header formats. So here also in the transport layer, the corresponding protocol will have its own header and the corresponding header format. Clear? I think keep it open, that is better. Leave it open. Okay. So do you understand so far whatever I said? So we are going to talk about how the communication in transport layer through the exchange of segments is going to take place. Any questions so far? So the situation over here that I explained is more realistic than what you see over here. So normally, when we are talking about an actual network, right? Typically, the payload, the data that is sent from the application to another application, it travels through multiple networks, right? If it was within the same local area network, then which layer would take effect? So both the sender and the destination within the same local area network, which layer? Which layer? Layer 2, right? Data link layer. But we are talking about a general scenario where some packet from IIT Kharagpur is sent to some packet, let us say in Delhi. So it passes through different networks. Okay. So when we talk about different networks, in between will come the routers, right? So this is the generic scenario that is shown over here. Have a look. You see that basically, whatever I have shown here is shown in a more generic way in this particular figure. This figure is taken from your textbook, so you can look at your textbook as well for this figure. So you see that let us say two organizations are there. So in this example, they have taken Sky Research and the other organization, let us say Scientific Books. So these two organizations, let us say this is IIT Kharagpur, let us say that this is IIT Delhi. Now, as I was telling you that each of the different computers over here, each of the hosts, they are going to have the corresponding stack, physical data link, network, transport application running on them. Same thing over here as well. Okay. So this communication that I was telling you between these two transport layers, this is actually shown over here in this double-sided arrow, blue color arrow. So this is the logical connection. This is not the physical connection. বেশি কমাবেন না, ওরা শুনতে পাবে না, ওরা শুনতে পাচ্ছে না, বেশি কমালে ওরা শুনতে পাচ্ছে না। আচ্ছা, কাউকে দিয়ে একটু জানলাগুলো খুলিয়ে দিন, জানলাটা দরজাটা হ্যাঁ খুলে দিন পুরো। আচ্ছা, so you understand now the concept. So in between it goes through different networks, and between these networks basically you have these different routers. This is the generic symbol of a router that is used often in literature. Okay, so always remember the routers are shown this way. So it goes through the local ISP, it goes through the national ISP with different WANs, etc. These are the switched WANs, right? So like that, and again goes to the local ISP and finally gets delivered to the end destination. So this is where this process to process communication is facilitated through this transport layer. Okay. So it is as if between this Alice in scientific research, in Sky Research, and Bob in Scientific Books. Let us say that this is Bob and this is Alice. So between Alice and Bob, again two names you will often hear, particularly in the context of cryptography. Always it is Alice and Bob. Okay, all examples. So here also they have taken the same names, Alice and Bob. So between Alice and Bob, basically it is kind of like a logical connection that runs between them. Physically it goes through the physical connectivity that is there between them, but logically as if you have the segments that are getting shared between them. Clear? So let us try to understand this concept of process to process communication. And often in interviews particularly, people ask, so what is this process to process communication? So this is what, this is a very important and central concept to transport layer. So you should understand this very well. So you see that you have a, let us say that you have a client and you have a server. You have a client and you have a server. So the client runs different processes, multiple processes. Same goes for the server also. Server also runs multiple processes, right? Now, the network layer, what it does, whatever we covered till yesterday, what it does is that from the client machine to the server machine or the other way, it is responsible for routing or sending the packet. It was also responsible for the IP addressing, etc. So the network layer basically did till that I know the IP address, etc. of the client and the destination and server. So I am responsible for sending the packet. Now this transport layer, what it is actually doing is between these two processes, it is facilitating. So that means that from, so let us say that this is your this thing. So from the network layer, you get the packet. Now this transport layer, what it is going to do, it is going to add certain header and it is going to encapsulate that information within this thing. So this becomes your segment. And this is the header of the transport layer. Now let us try to understand the concept of addressing. So what are the different addressing mechanisms in these layers? So in the data link layer, what is the addressing mechanism called? What is the address in the data link layer? MAC address. Very good. So in data link layer, the address that is used is the MAC address. That means that if you are within the same LAN, so the MAC address is sufficient to distinctly identify the sender and the receiver. And it is unique, as you know, right? It's a physical address which is in the network interface card. This physical address is basically stored. So this MAC address is used for addressing in the data link layer. In the network layer, what is the addressing mechanism called? IP address, right? Whether it is IPv4 or IPv6, IP address, isn't it? And then over here, what is the address? This is what we need to understand. So the address over here is done with the help of something called the port number. And this you know very well because you have been doing these assignments in the lab. So port number acts as the address in the transport layer, because I told you that ultimately to send the data to the applications, it has to be done through the ports, right? So the port number. So we need to identify these port numbers. So these port numbers basically are a combination of 16 bits. So how many port numbers can we have? We can have maximum 2 to the power 16 minus 1 because it starts from 0. Okay. So this is basically 2 to the power 16 minus 1, which is 65535. So these many port numbers we can have. But actually, although we can have this many port numbers, in practice, basically only two types of port numbers are used. One is called the ephemeral port number, the other one is called the well-known port number. Ephemeral port number and well-known port number. What is this ephemeral port number? Ephemeral means that it is temporary. It is temporary, it is short-lived. So basically, whenever a client wants to send something, let us say that this is the client and this is your server. The client is going to send through its corresponding port, and the server is going to also send and receive through its corresponding port. But it is the fact that the life of a client is very short. Why? Because what the client does is that whenever it needs to push something out, okay, it will, for a very short duration of time, it is going to send the data, and that's all. And again, when it comes, something comes, it will get the response. But for the server has to run for long durations of time, isn't it? So that's why at the server end, these well-known port numbers are used, which are kind of permanent for different applications. So for example, TCP, it runs in a certain well-designated port number. UDP in certain well-designated port number. So these are fixed. These are fixed and these are well-known. On the other hand, for client uses these ephemeral port numbers, the temporary ones. Something of this sort, like 52,000, is a kind of ephemeral port number, temporary ones. So let us now try to understand the difference between the use of IP address and the port number. IP address and port number. One of you please take the picture and share with your friends. You can put it on the Teams also. Done. So let us try to understand the role of IP address and the port number. This IP address, what it does is that it helps to select the actual address of the destination, or if it is the source, then the source to which the packet is going to be delivered. But then, it has to be sent to a particular application in that host. So this port number basically takes effect over here. So different applications are running on the host. So let us say that this is your let us say that this is your server. In the server, you have different layers, including the transport layer, the application layer. The application layer, basically, in the different different processes, basically you have these different applications that are running, and corresponding to every application, you have the designated port number. So basically, some application, okay, it is going to be addressed from the transport layer using that particular port number. So basically, the destination IP address basically helps you in selecting which server the packet that has come through is going to belong, whereas this port number is going to tell you that this is this application, to which it belongs. Is it clear, or should I repeat anything? Okay. Now, the organization ICANN is responsible for designating which port numbers belong to which category. So ICANN has divided the port numbers into 3 ranges: well-known, registered, and dynamic. So in the well-known category, we have the ports 021023. So the port for TCP, UDP, etc., HTTP, etc., and all these will come in this well designated port number. Okay, well known port number. Then we have the registered ports, so which are between 1024 to 49159. These are not assigned or controlled by ICANN. They can be registered with ICANN to prevent duplication, because if you want to use some port number, okay, you have to register to that port number, because if you do not register, then somebody else might be using it. So these are called registered ports between 1024 to 49151. And beyond this, basically 49152 to 65535, this is the maximum port number that one can have, 2 to the power 16 minus 1. Okay. So these are called dynamic ports, and these are neither controlled nor registered. These can be used as temporary or private port numbers. So this is basically this whole range of port numbers that could be used. So I hope that by now you understand that in your assignments you are doing, so far we are talking about port number, etc., etc. Now you understand what is this port number. So some of these different applications that use these different port numbers are given over here. So the protocol echo, there is a protocol called echo, right? In Linux you must have seen echo something. That's a protocol. So that uses the port number 7. These are the different protocols, right? Application layer protocols. Discard, users, daytime, port, like this actually, these different FTP you have done. SMTP is used for mails. Okay, SMTP uses port number 25, fixed. You cannot use anything else. DHCP uses 67, HTTP 80, SNMP server client, like this. So all these different port numbers for the corresponding application layer protocol is given over here. Now this is the socket address, which you are already quite familiar with. So in the transport layer, you need both the IP address and the port number to be able to make the connection, right? In your socket programming, you have been doing it, right? So the socket address basically is used in the transport layer as a combination of the IP address and the corresponding port number. So you see that until you get the IP address and the port number combination, you cannot make the connection all the way through at the bottom as well as on the top. For the top, you need the port number. For the bottom, you need the IP address. So this is called the socket address. So now comes the concepts of encapsulation and decapsulation. So this is what happens at the sender side. You have the transport layer, you have the application layer at the client. At the server also you have the same transport layer and the application layer. Now you see that this particular process wants to communicate with this process, client process with server process. What it does, it produces the message. The client will produce the message. This message is going to be pushed to the transport layer. Now what this transport layer is going to do, it is going to fill with the corresponding header in transport layer, and through this logical channel, or actually through the physical channel like this, that means network layer, this, that, etc., or the logical channel, it is going to send to the server. You understand this concept of this logical channel? Any doubt about it? Very good. So now this corresponding server transport layer is going to receive this particular segment, okay, with the corresponding header. It is going to remove that header, transport layer header, and going to pass on the message to the application layer, which is going to be accessed by the corresponding process because the port number is already fed into it. So this transport layer knows that which port number it is going to push this message through, because the port number was already there in that message. So this is how this encapsulation and the decapsulation basically takes place at the transport layer. We also need to understand the concept of multiplexing and demultiplexing at the transport layer. At the physical layer, you know what is multiplexing, what is demultiplexing. We have already covered towards the beginning of the course. The same concept basically holds also for the transport layer, because when you are talking about a server, let us say, a server is receiving multiple client connections. Okay. So you see that the server has to demultiplex the different connections that are coming through. At the client end also, what it is doing is, if you just look at a single client also, different processes corresponding, their corresponding packets are coming, all of which will have to be multiplexed at the client end and has to be forwarded as different packets. Okay. Actually, this is strictly not packet. I wouldn't call it packet. This is called segment, right? Because we are talking about the transport layer over here. But the concept is basically the same, whether you call it packet or the segment. So the transport layer at the source will act as the multiplexer, and at the receiver, basically the server, it is going to act as the demultiplexer. Let us now try to understand the concept of pushing and pulling. So you see that somebody is the producer of the data and somebody is the consumer of the data in the whole process. So if you are talking about some client which wants to send some data to the server, the client has to push the data to the server, and in the process the server becomes the consumer. On the other hand, if the server pushes some data to the client, it becomes the producer and the client becomes the consumer. So who becomes the producer and who becomes the consumer depends on your particular situation in hand. But irrespective of that, you have the scenario like this: you have a producer, you have a consumer. The producer basically produces the data and it is going to be delivered to the consumer. Okay. Now if the data is pushed from the producer to the consumer, the data is pushed, right? Producer is producing the data continuously. Think of it this way, that you have an application layer which is running and it is sending the data, right? Streams of data are coming. Now those streams of data will have to be sent to the other end also, right? So this particular end basically acts as the producer. Now this producer sends some data to the consumer. So one of the problems that is going to happen is what? Is the producer might produce at a faster rate compared to how much the consumer can consume. If that happens, if it produces faster than what the consumer can consume, then what will happen? The segments are going to be dropped, the packets are going to be dropped. So this is where this flow control comes into picture in the transport layer also. So where did you learn about flow control so far? In the context of what? Layer 2. In layer 2 you have learned flow control, right? Where we were exchanging frames. Here also this concept comes where we are exchanging segments. Okay. So same thing basically over here. So this is flow control has to be enforced, and over here basically this consumer basically requests the producer basically delivers. So these are the two scenarios that one can have. So you see, whenever we talk about all these, we have to also take these into account. Flow control, we have to take into account error control, and there is something called congestion control. So the first two, flow control and error control mechanisms, whatever you have learned in the layer 2 are applicable over here as well. Because again, if we are talking about this sliding window, stop and wait, go back in, selective repeat, same thing. But here in the context of these segments that are going to be exchanged. So that's why mostly I will not be covering those things, but in your book actually you will find these concepts explained. But basically it's the same thing, exactly the same thing. In the interest of time, I'm not going to cover, but remember that these are applicable over here in the transport layer as well. So you might be getting a question now, not saying that frame 1 sent, 3 frames sent, 2 lost. Here I might be saying that 3 segments sent, 2 lost, go back in. Right? So at that time, don't think that, oh, now how the segments will be. Same, exactly the same thing. Okay? Now, so you understand that this flow control between the sender and the receiver has to be enforced if the packets are pushed from the producer to the consumer. Okay? So same thing, can go over here as well. So in both directions, basically, you have to be careful about this flow control. But ultimately, when you are talking about flow control, let us just say that this is the producer and this is the consumer, right? So you see that the flow control has to take effect from end to the end. That means that over here you need to have flow control, and also between the layers you need to enforce flow control. So end to end flow control has to be enforced. For error control, same thing, basically, detecting and discarding corrupted packet segments, whatever you call it, so basically, this would be strictly called the segments. Keeping track of the lost and the discarded packets and resending them, recognizing the duplicate packets and discarding them, buffering the out of order packets until the missing packets arrive. Exactly the same thing that you have learned for the link layer. Okay. Congestion control is something that you have not learned so far. So congestion can happen, right? Because so there might be some bottlenecks through which multiple producers are sending data. So at the bottlenecks, basically bottleneck links or the nodes, yeah, so the capacity might be exceeded. So the congestion can happen. Capacity of these intermediate nodes or the links can exceed, because of which congestion can happen. Exactly the same thing as in the road networks also, the congestion happens. Here also the same thing. So congestion in the network may occur if the load of the network is greater than the capacity of the network. So congestion control basically tries to make sure that the load on the network is kept below the capacity of the network. So here in the transport layer, we talk about two types of services. One is called the connection-less service. The other one is called the connection-based service. The transport layer supports two types of services, connection-less as well as connection-based. These two terms, if you recall, we encountered earlier as well in a different context. Whenever we say connection-less, that means that without establishing the connection, you can keep sending the units, And whenever it is connection based, that means that first the connection has to be established between the server, client and the server, or the two hosts, and then only after the successful connection is established, then only you can send your data. So there are two protocols in the transport layer. One is called the TCP, the other one is called the UDP. These two protocols follow. The first one, connectionless, is UDP, and the next one that I'm going to cover, connection based, is the TCP. So obviously connection based means the connection is established, so there are more guarantees. So that's why it is a TCP is called the reliable protocol. It gives you more reliability. Whereas UDP, it is less reliable. But then the question is that why do you want to go for less reliable ones? Because it depends on the application. Certain applications actually, whenever you go for establishing the connection, that means that you are wasting more resources than the guarantee that you actually require. So there is a trade-off between these two. So in some cases TCP suffices, in some cases UDP suffices. So it depends on the application that you need support for. So let us try to understand this connectionless service in this context once more. You already know it. You can map your previous understanding with whatever I say over here. So let us say that this is your client and this is your server. The client transport layer and the client processes are shown. Server transport layer and the server processes are shown. If you look at the timeline diagram corresponding to this, the client process, let us say, that sends the messages 0, 1, 2, etc. The transport layer, it is going to put them as these different packets 0, 1, 2, etc. And you see, it might so happen that packet 0 is received, and after that first packet 2 is received, and then maybe packet 1 is received. So you see that these messages could be delivered out of order. So connectionless, basically connectionless protocol doesn't guarantee, connectionless protocol out of order delivery of packets is possible. It doesn't guarantee the orderly delivery of the packets. For orderly delivery of the packets, basically you need to fall back on the connection based protocol. Connection oriented, it is called connection oriented. Is this clear scenario? Now, in connectionless, the source process, the application program, needs to divide its messages into chunks of data which is acceptable by the transport layer, and then deliver them to the transport layer one by one. The transport layer then treats each chunk as a single unit without any relation between the chunks. When the chunk arrives at the application layer, the transport layer encapsulates it in the packet and sends it. To show the independency of the packets, you assume that the process client has 3 chunks of messages to send to a server. The chunks are handed over to the connectionless protocol in order. So let us say that this is your UDP protocol. However, since there is no dependency between the packets at the transport layer, the packets may arrive out of order at the destination and will be delivered out of order to the server process. So this is basically how the connectionless service works from the application layer message to the application layer, from the application in the client side to the application in the server side. Now let us look at, in contrast to connectionless, how this connection oriented service works. So you try to remember this diagram over here where the messages are delivered out of order and there was no connection establishment. But in connection oriented, what happens is, first you have to establish this connection. First, you have to establish this connection. So after the connection is established, then the data are going to be transferred. And once the data are all transferred, the connection has to be closed. It is also called connection tear down. Okay. So you see that the client process basically sends a connection open request to the transport layer, to its transport layer. Then the transport layer from the client and the server, so they handshake and this connection is established. After that, these messages are delivered. Now the interesting part is that here also, let us say that the message 0 is first delivered, then message 2 is delivered, and then maybe the message 1 comes, right? But what in connection based service, connection oriented service, what it is going to do, it is going to order these messages before delivering to the server process. So essentially what it is going to do is when this packet 2 or the message 2 arrives out of order, it is going to put it on hold until it gets the message 1. And then the messages 1 and 2 are going to be delivered. This is the main difference basically. So after the packets are delivered, then the client basically sends a connection close request and this connection tear down process is initiated. Is it clear? All of you know the state machine, finite state machine. The exact details of the working of this connectionless and connection oriented are captured in this finite state machine FSM diagram. Okay, you have done automata theory, right? Something very, FSM, right? FSM, So it is captured in this. So please try to go through the different steps and try to convince yourself how it works. So you see, when you talk about certain applications like YouTube or whatever, where the data are streamed, you need to have the stream delivery service. So the stream delivery service basically talks about the streams of bytes which will have to be delivered. So at the producer end, the streams of bytes are produced, and the receiver end, basically the consumer end, the streams of bytes will have to be received. So the sending process basically it writes to this thing, the connection, and the receiving process basically reads from this connection. So if you are talking about TCP, at both the ends, the transport layer protocols, the sending process basically sends these streams of bytes, and through this logical pipe that is going to be there, at the other TCP end, these are going to be received by the corresponding, process that is connected to it. So that's the overall concept of transport layer. So what we will do now, any question? Somita, fine? Any doubt? Any of you? Chalo. So what we'll do is we'll take a 5 minutes break and we'll reassemble. Okay?